video, I want to prove that the slopes of perpendicular lines are negative reciprocals of each other and that when multiplied together, you get -1. So to begin, we're going to construct our perpendicular lines, and I'm going to call this red line M. I'm going to call this green line N. And you can see that they're perpendicular because of this 90-degree angle right over here. I'm then going to construct a horizontal line that is horizontal to this intersection point. I'm going to call this intersection point, let's say O. And then I'm going to draw a vertical line that is perpendicular to the horizontal line that we just constructed. And it's going to touch the green line at A. And I'm going to call this intersection between the two construction lines B. We're going to do the same thing for the red line as well. I'm going to call this this point C. Call this this intersection point D. So now we can pretty much begin our proof. So the slope of the slope of the line N is basically going to be constant throughout. So that is to say the slope of a smaller line segment, let's say AO, is going to be the same as the slope of the bigger line segment or the bigger line N. And same thing for the red one. So the slope of M is going to be constant throughout, which means that the slope of M is also going to be equal to the slope of DO. Alright, so what exactly is the slope of the green one, of the green line? So we just said it's equal to the slope of AO. And so what is the slope of AO? Well, it's going to be rise over run. So that's going to be AB over BO. Right? Rise over run. And same thing for the red line. The slope of the red line is going to be equal to the slope of DO right over here, as we said earlier. And what is that going to be? Well, that's going to be rise over run. But here's the thing. Your rise over here, as you can see, is going down. So which means that so normally the length of, let's say, CD is going to be a positive number. But because we're looking at, well, you can pretty much just imagine this inscribed on or not inscribed, but basically on the Cartesian plane. So if we're going down, like the CD is, well, the length of CD is going to be equal to negative now. We have to put a negative sign, or not the length of CD. The length of CD is going to be positive, but the rise is going to be negative. So we're going to put a negative CD over here for the rise, and the run is going to be OC. All right. So now we have the slopes of the lines written out. Well, this doesn't really tell us anything. In order to tell us something like how these two are related, we first must prove a relationship between the triangles, because we're basically just using triangles in order to get our numbers here. So in order to do that, I'm going to call this angle alpha, this angle, and this angle beta. So alpha plus beta plus this white angle is going to be equal to 180 degrees. Alpha plus beta plus this white unknown angle is going to be equal to 180 degrees. Well, and by the way, just saying, this white unknown angle is actually going to be equal to 90 degrees. 90 degrees, because, well, these are perpendicular lines. So that's why this is actually 90 degrees, but it doesn't really matter. At least for now. Actually, no, it does matter. I'll change this question mark to a 90 degrees. So alpha plus beta plus 90 degrees is going to be equal to 180 degrees. Well, if we look in this triangle over here, ABO, you have angle alpha. Actually, let me do this in a different color. in this triangle ABO, we have angle alpha plus 90 degrees plus some unknown angle equals to 180 degrees. And we know this is equal to 180 degrees because that's how many degrees are in a triangle. So what is this unknown angle? Well, alpha plus beta plus 90 degrees equals to 180 degrees. From this triangle, we know that alpha plus 90 degrees plus some unknown angle equals to 180 degrees. So what is the unknown angle? Well, the unknown angle, the only thing that's missing is beta. So this unknown angle over here is actually going to be beta. And we can do the same thing for the triangle on the red side. So we have, in this triangle, we have beta plus 90 degrees plus some unknown angle equals to 180 degrees. Let me write this equation, the equation for the red. Beta plus 90 degrees plus some unknown angle equals to 180 degrees. Well, what is this unknown angle? The only thing that's missing is this alpha, which means the alpha has to be the missing angle. So this is actually alpha right over here. All right. So knowing the angles, well, now we just proved that these two triangles are similar because by AAA or by angle, 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 technically angle, angle also works, but I'm just going to go with triple angle. By AAA, triangle ABO is similar to triangle OCD. All right. So what if these triangles are similar? Like who cares? Well, now that these are similar, well, similar triangles tells us that sides are proportional, so the same sides are proportional. And because the sides are proportional, that means that the ratios of sides are equal. And you can imagine this. I'll draw in another triangle. So let's say we have this small white triangle and a big white triangle. And we're saying that these two are similar. Well, basically, similar triangles, you have it so that the sides are proportional. So let's say this red side is not going to be equal to this red side, but this small red multiplied by some number, let's say multiplied by some number y, is going to equal to the length of this red side, right? But since ratios are going to be, let's say, red over green, for example, this green line over here, red over green in the small triangle is going to be equal to red over green in the big triangle. Over green in the big triangle. Because red gets bigger at the same pace as green gets bigger. So because they're both multiplied by, let's say, some factor y multiplied by y. Well, so that means that the ratios of sides in similar triangles are equal. All right, so what does that mean for us? Well, the ratios of, let's say, the slope of the green, AB over BO, well, it's going to be the same as the ratio of, it's going to be equal to OC over CD. And we know this is true because, well, AB is going to be adjacent to angle beta. So OC is adjacent to angle beta, and BO is going to be opposite to angle beta, and opposite to angle beta is CO. So that's how we know that AB over BO, which is also the slope of the green line, is going to be equal to OC over sorry, it's not CO, it's CD. OC over CD. And again, this is true because the ratios of sides are equal in similar triangles. Well, guess what? So I'm gonna call this, so OC over CD. Well, look at the relationship between the slope of the red line and OC over CD. It just seems that the numbers are flipped, right? Flipped and negative. So in other words, OC over CD is going to be equal to -1 over CD over OC. Right? So basically we know that OC over CD is basically equal to the negative reciprocal of CD, or of the slope of the red, basically, right? Because you have, well, you just flip these and you multiply by a negative sign, so to get OC over CD. If you multiply, if you take the reciprocal of the slope of the red line and you multiply it by -1, you're gonna get OC over CD. Or in other words, OC over CD is going to be equal to -1 over CD over OC. And if you look at this, AB over BO is equal to, let me do this in a different color. AB over BO is going to be equal to OC over CD. And what is OC equal to CD also equal to? OC over CD is also equal to -1 over 1 over CD over OC. Or actually, hold on, I'm pretty sure there should be a negative sign right over here. Yeah, negative sign, because it's a negative reciprocal of the slope. So yeah, sorry, I forgot there was a negative sign over here in the denominator. So again, AB over BO is equal to OC over CD, and OC over CD is also equal to the -1 over negative CD over OC. And negative CD over OC is also slope of red. I'm just going to write M of red. I'm going to call this M of green, or slope of green. So the slope of green is equal to, I'm going to call OC over CD X. So the M of green, slope of green, is equal to X. And X is also equal to the slope of red. Or actually, no, it's equal to the negative reciprocal of the slope of red. So therefore, this means that the slope of green is equal to the negative reciprocal of red, because they're both equal to X. So let me write that down. Slope of green, M green, is going to be equal to negative reciprocal of slope of X. Negative reciprocal of M red. Or yeah, not slope of X, slope of red. Or in other words, this also means that M green multiplied by M red is going to be equal to -1, right? Because you just multiply the slope of red on both sides. So this is basically the proof that the slopes of perpendicular lines are the negative reciprocals of each other, and that when multiplied by each other, they are equal to -1. If this video has given you value, or you like this concise, non-BS way of teaching, then please consider supporting the channel. Regardless, thank you for your attention and good luck with your studies.